We have discussed a few topics on friction in the previous videos, and in this video I'm going to talk to you about ladder friction. So ladder friction. As in the previous cases, you just need to have a clear understanding about force resolution and moments, taking moments of forces. I have discussed these cases in previous videos, so if you haven't already done so, I would recommend you to go through those videos before moving into this topic here. So what you have here is a ladder supported on two surfaces. You have one surface here and another here. As mentioned in the previous cases, you will have a reaction from here and another reaction here. The ladder will be sliding downwards on this surface and towards right on this surface, so you will have a friction opposing that movement, and here you will have a frictional force like this. So this is your reaction 1 and your reaction 2. You have a frictional force 2 and a frictional force 1. Obviously the friction depends on the coefficient of friction on the surface. You know the friction F is equal to mu times Ra, where mu is the coefficient of friction. And also you will have a weight of the ladder vertically acting downward from the center of gravity of the ladder. So usually if it's a ladder, the half length of the ladder will be the point where the weight of the ladder will be acting. So this is only force unless there is a man or an object on the ladder. If there is no object, then this will be the only force acting on the ladder. So you need to find two cases where the maximum, the case 1 will be the maximum forces in the system, in this system. By force I mean the reactional force and the frictional forces. And then you have an equilibrium case. How do you find the equilibrium? We have the famous 3 equations, or the summation of forces in x direction equal to 0, summation of forces in y direction equal to 0, summation of moments equal to 0. These are the 3 conditions. So if you can prove the moment about any point is 0, then you can say that is the condition for the equilibrium of this force system. Now let's see if we can do a simple question, a simple problem on this. I just shown the frictional forces and the reactional forces I discussed earlier on. I shown it here. You have a point A, B and C, a ladder of weight 100 Newton acting, and the total length of the ladder is 13 meter, and you have a 5 meter here. So for the equilibrium of this, let's say this surface have a coefficient of friction of 0.3, and let's assume this is a smooth surface, which means there is no coefficient of friction on this surface. That means the frictional force on this surface will be 0. If it's a smooth surface, obviously you won't have any friction, but if it's a rough surface, you will have a coefficient of friction, and your frictional force will be, as I said earlier on, it will be force equal to mu into reactional force. Now for the equilibrium of this system, you see the total force acting downward is 100 Newton, and for vertical equilibrium you have 100 Newton acting downward. You don't have a force here, so that is 0, and you have a reaction here, so Ra is equal to 100 Newton. And because you have a coefficient of friction 0.3 here, your frictional force at A is equal to mu times Ra, that is equal to 0.3 times 100, that is 30 Newton. Now that is a maximum force, frictional force available in this this point. So as long as when you take the moment, as long as the force on this surface is less than this 30 Newton, then your system is in equilibrium. So the opposing force at in this system will be only reaction at B. That is the only force here, because you have a force of Fa acting in this direction, and you have a reaction force B acting opposing this force. Ra is already balanced by this 100 Newton. Now this is the maximum available force in this force system, 30 Newton, and Ra is 100 Newton. Now let's find out this distance before taking the moment. We take the moment to calculate the equilibrium of the system. That is the third condition. We have balanced the x direction and y direction. Now you need to prove moment about any point is equal to 0. So for that we can find this distance. So y is equal to, because it's a right triangle, this is 13 squared minus 5 squared, which is equal to 144. That is equal to 12 meter. So you have 12 here. And the center of gravity of this will be half length. So this point you have is 6.5. And because this is half the length, the point of action of this force, this will be half the length of this 5, which is 2.5. I'll explain that once again. Your center of gravity will be acting at the center of the length of the ladder, so that is 6.5, and because it's a right triangle, this line, if it is coming from the half length of the ladder, it will cut this plane at half length, which means the length through which the line of action of this pass through will be half length of this total length, that is 2.5 meter. Now we can take the moment about any point and see the reaction at B to see if that balances the force, frictional force at A. Now once again I have shown that here you have 30 meter, 5 meter and 12 meter, and I just missed to show this. This is 2.5 meter up till here. So taking moment about A, you have Ra passing through A, so no moments, Fa passing through A, so no moments, and 100 Newton passing at 2.5 meter perpendicular distance from A, and that will be creating counterclockwise moment, so that will be a positive sign, and the moment will be 100 times 2.5. Now next force Fb is there is no force because it's a smooth surface, and Rb is passing at a distance 12 meter from A. A is the point here, so the perpendicular distance between line of action of Rb and A is 12 meter, and that is creating a clockwise moment, so that will be opposite to the sign of this 100 Newton force. So you have minus Rb times 12 equal to 0. So that is a equilibrium condition when you consider moment about A. So you have Rb is equal to 100 into 2.5 over 12. So that is 250 over 12. I'm just using my calculator here. You have 20.833. So for the equilibrium, the Rb in this case will be 20.833 Newton, and we know the maximum force available at Fa. We have calculated that using the force system, that is 30 Newton. Fa is 30 Newton, and that is the force opposing the Rb. So as long as Rb is less than 30 Newton, this system will be in equilibrium. So that's what we have here. The maximum force available in x direction opposing Rb is 30 Newton. So as long as RB is less than 30 Newton, 30 Newton is the force, frictional force at A. So as long as RB is less than 30 Newton, this ladder system will be in equilibrium. So we can say this is in equilibrium as long as RB is less than 30 meter. Now, if you have a person standing on the ladder, then you will have a different force. Say for example, the person standing here, then your line of action will be different, and your reactional force will be different, so your frictional force will be different. The things will change. Hope this explained the ladder friction concept. Once again, you have a ladder, total length, and a weight of the ladder acting at the center of gravity. The forces you have in a ladder system will be a reactional force at two mating surfaces, and depending on the surface friction coefficient, you will have a frictional force at 2 points of contact. At this point, the ladder will be moving or sliding downwards, so the frictional force will be opposing that, and at this point the ladder will be moving in this direction, and therefore opposing force will be opposite to that, and that is your frictional force. And your frictional force is mu times R, where R is the reaction, normal reaction, and mu is the coefficient of friction. Hope this explained the concept of frictional ladder friction, and I'll see you with new concepts in next videos. Thank you.